Hello friends, today I am going to discuss linear algebra problem and how to write algorithms. So just everybody knows linear algebra. If you are doing a graduations like a science graduate, the mathematics, physics and other science subject, and second if you are doing like a engineering, so this is the most important for everyone. So let's see. So just if linear algebra, like Python is very important for the linear algebra, like a vector matrices and multidimensional arrays. So vector matrices and arrays of the higher dimensions, and they are essential tools in numerical computing. So computationals that are formulated like the we can say that to be the vectorized. Vectorized means computing eliminates the need for many explicit loops over the array elements by applying a batch operations on the array data. The result is concise and more maintainable code, and it enabled delegating the implementation of array operations to more efficient low-level libraries. So vectorized computations can therefore be significantly faster than sequential element by element computations. This is a particularly important in an interpreted language such as a Python's. So just we have already understand like a Python is a scientific computer environment. Efficient data structure for working with the arrays are provided by a NumPy library. So the core of the NumPy is implemented in C and it provides efficient functions for manipulating and processing array. So let's first we need to the import NumPy. So just I have imported. So NumPy means what is the NumPy? The NumPy library provides the data structures for representing the rich variety of arrays and method and functions for operating on such array. So NumPy provides the numerical backend for nearly every scientific and technical library for Python. So first we have already imported like a NumPy. So just I have imported, and I am going to the create a data array here. So you could see here like a data numpy dot array I have created, and 1 2 3 4 5 6, and we can see this data. So you can see here data. So after imported, I have created like a data, and data dot n dimensions means number of dimensions, like a axis you can see here. Data we can see. So let's see, I have created a data. Now numpy n array, and you can see your data. So your data look like this way, and if you want to see here the what is the ndim means data.ndim means number of dimensions, like axis in this data. So you can see the 2 dimensions here, one is the rows and another is column. Data shape, so you can see the tuple that contain the number of elements, so each dimensions of the array here, so you can see it look like a 3 rows and 2 columns. And this is the size, so the total number of the elements in the arrays we can see here like a size. And data type, we can see here like a data types means the data types of elements in array. So like here data types integer 64, and this one is the n bytes means number of bytes used to store the data like a 48. So I hope is it clear, these are the basic attributes of the ND array class. Now after that we have just I am going to create like a new array 1 2 3, and data type I have already mentioned like a NP array. So you could see here. Similarly we can see like a floats, complex, so look like a floats, so integer, floats, complex. Okay, so you can see like a complex also. So similarly let's see, just I have created the d1 and d2, these two are the values, one is the float, another is the complex, and I am going to try to edit both of them. Is it possible? So np floats is the dependent alias for the bulletins floats to the silence of the depressions the numpy 1.0. So similarly just d will equal to d1 plus d2 is the real imaginary part, d1 plus d2 is a real imaginary part, so we can see here real imaginary and all are 0. Now next I am going to create here the one dimensions like a data 1, so this is called a one dimensions, and number of dimensions we have already discussed and number of shapes we have already discussed. Create the 2 into 3 with the zeros. So 2 into 3 like a numpy the 2 dimensions array. So data 1 we will see here it has been created like the 2 dimensions array, and you can see like a shape this one 2 is to 2. Create 2 into 3 with the zeros. So let's see the 2 into 3. So 10 rows and 10 column. Similarly now np zeros 2 is to 3. Shape we can see, dimensions we can see here. One is the from operating system import the weighted results like a 10 into 10 like a float 64, and we are going to the create the one more variable like 4.3 will multiply np once like a 10. So we will see here 0 1 2 3 4 5 6 7 8 9, so it will start from the 0. So we can see here it will start from the 0. Similarly just np dot full, if you write here np dot full, so data type like here real number, imaginary number we have already. So data type dot full, so you can see here like x2 is another variable. Look here, 10 4.3 10 times it has been printed. Now generate 1 to 10 value. It's exactly np dot arrange, so we can generate like a 0.0 and 10 value till 9, and the difference between the two values like 1. So this is the different data types of these values. Next, array. After that we can see also like a logarithm sequence, so we can also create like a log. So np dot log space, it will start from 0 2 and 5, so 1 log 3 10 31.66 and 100. So logarithm functions means functions np dot log space is similar to np dot line space, but the increments between the elements in the array are logarithmically distributed, and the first two arguments for the start and end value are the power of optional basis keyword argument, like default to 10. So it has been generated like this one. Next is the mesh grid. Mesh grid means multi-dimensional coordinate grids can be generated using a functions np.meshgrid. So given the two one-dimensional coordinates array, any array contains the sets coordinates along given dimensions, we can generate the two dimensions coordinate array using like np.meshgrid functions. So let's see np.meshgrid, and you can see like a -1 0 and 1. Similarly np.array is -2, and we have created the y is the another value. You can see there -2 0, and x and y going to the create like a np.meshgrid x comma y. So -1 0 1 -1 0 1 -1 0 1, it has been created. So the common uses, the case of the two dimensions coordinates arrays like x comma y, x and y. So it is to evaluate the functions over two variable x and y, and this can be used when plotting of functions over the two variables. Similarly, like a color map plots and counter plots, like suppose if you take like a x plus y whole square. So just if you take like a one variable like x plus y whole square, so x we have already taken and y we have already taken, and you can easily get value x plus y square. And similarly we can also take like a x plus y whole cube. So it is also possible to generate the higher dimensions coordinates array by passing a more array as arguments to the np.meshgrid functions. And now the functions np.meshgrid, np.ogrid can also be used to generate a coordinates array using slightly a different syntax based on indexing and slicing object. So creating uninitialized array. To create an array of a specific size and data types, but without initializing the element in the array, to any particular value, we can use the functions np.empty. So the advantage of using these functions, for example, instead of np.0, which creates an array initialized with a 0 value elements, is that can avoid the initiation steps, and if all elements are guaranteed to be initialized later in this code. This can save a little bit of time, especially when working with a large array. So like here you can create here, look like this, it has been imported, and you can create a definer fx and y will equal to np.once like x. So creating an array with properties of other arrays. So y will equal to np once we have created underscore like x and return y. So let's see what happened. It has been created. Now creating the matrix array, now identity. So it has been created 4 rows and 4 columns. So creating a matrix like a matrix or 2 dimensions array are an important cases for numerical computing. So NumPy provides a functions for generating a commonly used matrices. So np.identity means like identity matrix. It's a similar functions to numpy.I generate matrices with the ones on a diagonals. np.I, and if you write like a 3, 4, something like this, 4 and k will equal to 3. So let's see, it has been generated like this, and 4 and k will equal to 3. You could see like this. So the construct the matrix with the arbitrary 1 dimensions array on the diagonals, and we can use the np.dig functions, diagonal functions, so which also takes the optional keyword argument k to the specify an offset from the diagonal. So the time demonstrate here, look here, just we have taken like a 3. So look here, your diagonal keyword argument, so we gave a third argument to the np.arranged functions also. So we specify the step size of in the enumerations of elements in the array returned by the function. So let's see, just create a diagonals also. So it will start from the 0 to 20, and it's look like a 2, 4. Diagonals should be like a 2, 4, 6, 8, multiple of the 2 till 18. You can see here. So we can easily create. Similarly, we can change here enhance of the 2. You can get the 3. So 3, 6, 9, 12. So create a diagonals. You can easily create a diagonals according to your opinion. Next, the indexing and slicing. So the elements and sub-array of the NumPy array are accessed using the standard sequence brackets notations that is also used with a Python list. So with the square brackets, a variety of different index formats are used for different types of elements section. So 1 dimensions array, just if you write here like expressions like you can create a square brackets, and you will write the here like some index and slicing operations for a numpy array. So if you write a will equal to np dot array 0 to 11, and just I am going to create. So this array has been created, like it will start from, so with the end is value is 11, so we'll see your value like 10. Now if you write here like if you want to see like a fifth elements, so you write here 4. If you want to see like the first element, so you can put here the 0, could see here the first element. If you want to see similarly something, but if you want to like see the range of the elements like 1 to -1, so you could see here it will start from 1 1, and the end of this means -1 is the your second last element. You could see here till here. So -1 means the last elements is not included. So second last element till we are discussing here the second last elements. Similarly, just if you write the like a square bracket, it will start from 1 and -1 and 2. So let's see, just 1 is as it is, and it will start from like a -1, like a 3, 5, 7 and 9. So it will start from here, so you need to get here the differences between the 2 2 2 2. So after that we will see here, if you want to see like so to select a range of elements, say from the second last elements. Okay, so if you write here like a -5 and slicing, so you could see here -5, so your element will start like a -5, -1, -2, -3, -4, -5. And similarly, so you can see the -5, so it will start like a -5, like a 6, 7, 8, 9 and 10. So double slicing and -2, we can see here your array can be changed, so it will start from end. So you can see here your array has been started from like this. So to reverse the array and select only the every second value, we can see here. So I hope it's clear. So next is the multi-dimensional array. So now the multi-dimensional array means like a f lambda m n and slicing m n plus 10 multiplied m. So this is the multi-dimensionals, and I am using like a from functions f I have created and 6 into 6. So you could see here matrices data type like an integer. So multi-dimensional array means with the multi-dimensional array elements selection like those introduced in the previous sections can be applied like each axis. So each element matches the given sections, write some specific rules here given. So we can extract the columns rows from the two dimensions array using a combinations of slicing and integers indexing. So extract the second column. So yes, it's possible to we can extract a second column. So we can write the slicing comma 1. So look here, the only we can see the second column. And similarly, just if you write the 1 comma and this one, it's not a extract. Sorry for that. I think you need to write here this one. So you could see here like a second column here 10, 11, 12, 13, 14 and 15. And if you write here slice -1, slice -1, so we are extracting like this here, only first row and first column. Now the every second elements starting from a 0, so we could write here from here. So double slicing, and we can see here it will start 0 to 4, 0 to 4. And similarly we can write the 20, 22, 24. So this is a way we can represent like your B. It will start from 1 to 5, and it will start also the 1 to 5. And if you write like a B and slicing comma slice, so it will be equal to 0, so I think it's clear. So assigning the new value or to the elements in array B, and which is created from the array A, also modify the value in A. Now after that, just creating a new variable like A, and reshaping and resizing this value. So let's see, just I have created like this one, data dot np array, and now np dot reshape data 1 comma 4. So it has been created like this, and data reshape, it has been reshaped 1 2 3 4. Data dot flatten has been 1 2 3 4. Data dot flatten dot shape has been created. Data np dot array 05 has been created, and data np dot new axis we can create here like a column. Now the row, the data dot np and new axis has been created, look like this. np dot arrange like a 5, it will start from the 0 1 2 3 4. Next, look here. So reshaping and resizing, when working with a data array, it is often useful to rearrange array and alter the way they are interpreted. For like example, in cross n matrices, array could be rearranged into like a vector of length n square. So np dot reshape, np dot n dimensions array dot reshape n dimension array flattens, ravels, squeeze, expands, np dot new axis, np dot transpose, Concatenate means create a new array by appending array after each other along with the given axis. NP resize, NP appends, inserts, deletes. So reshaping an array does not require to modify the underlying array data. It only changes in how the data interpreted by redefining the array strides attributes. An example of this type of operation is a 2 into 2 array that is reinterpreted as a 1 into 4 array. So same data, just I have taken VATEC data 3 times, so we can see here and stacks data new axis, and similarly just we can use the arithmetic like a mathematical operations. We have created x and y variables and we can edit, we can subtract, we can multiply. We could multiply here, don't worry. So we could divide like a one by others. We can also get like a square. We can also write a 2 to the power x. So multiply with the x something. Okay. So we can also write a 2 to the power x. So number of the ways we can easily get. Let's see the reshape this data. So we can reshape this one is in here 1 2 3 4 5. So we can easily reshape like a 2 into 2. Similarly just np.array 1 2 3 4 means x divided by z, just this one x by z is not okay, don't have the z here, so we can't take here. So x by y, if you write here like so, we can create here. So same way we can easily concatenate means just added here. So z and z we can create. Next the element wise functions. Just element means first we can create here the np.len space, and we can also apply like a sine, cos, tan, like all trigonometric. np.pi x, np.round decimals, np.sin x square, np.sin cos x square, np.sin x square plus np.cos x square can also get here. So all trigonometric identity we can also like inverse, cos inverse and sin inverse. NP cos h. We can also subtract trigonometric value. We can also multiply here this value. And now the sum aggregate functions like we have created. I am creating like this functions, and I want to get here, this is the random normal value, and I want to get here this mean of this value, like the standard deviations of this value and variance of this value. Okay, so this is the best way we can. Let's see, just these are the basic things, and similarly if you want to go the some standard So the SIMPy is the most important library. So you can use like a Py, Infinity, and these things. So I try to discuss in the next time. Thank you very much.